So in this situation here, we've got a car traveling with a speed of 15 meters per second, positive 15. So we should set up our coordinate system. We have the positive direction and the negative direction. We have a car that is traveling with a speed of plus 15 meters per second. It passes a bicyclist. So if the car is headed to the right and passes the bicyclist must be on the right side, the positive side. The speed of the car relative to the cyclist is 12 meters per second. So in other words, the bicyclist, when they're looking at the car, thinks the car is traveling at 12 meters per second. It thinks it's traveling more slowly than it really is. So what we want to know is how fast is the bicyclist going? And we're given 4 different choices. Now, it's easy to get caught up with considering these cases. Let's consider the simplest case, the choice they didn't give us, which is the velocity of the cyclist is 0. So if the bicyclist is 0, the bicyclist is going to think that the speed is 15 meters per second. If the bicyclist is traveling in this direction, toward the right, positive, then the bicyclist is going to see that it takes the car longer to catch up to it. And if it takes longer to catch up to it, that means that the car must be traveling more slowly. So the velocity must be then less than 15 meters per second. Now let's just consider the other case. If the bicycle were traveling in this direction, the car is going to catch the bicycle faster, sooner than it did before, which means it must be traveling greater than 15 meters per second. So in this case, we know it's actually 12 meters per second, and that matches less than 15 meters per second. So that means the bicyclist must have a positive velocity. So that takes those 2 out right away. So then the question becomes, is it 1.5 or 3? Well, in this case, if the bicyclist were traveling 3 meters per second, then the car would be catching up to it at 12 meters per second. If at 3, if at 1.5, well, then the car would catch up to it sooner, as if it were traveling faster, and that sooner would be 13.5 meters per second. So we can see then that it must be plus 3 meters per second. The trick here, again, is to imagine the case they didn't give us, which is when it's 0. And then first consider what happens if it's in one direction and then the other. And it's only then that we can tease out exactly what is occurring. And that finishes us up with that question.